Section 7.6, Proportional Lengths. When we talk about proportionality, we can talk about segments to start with and then apply it to shapes and polygons. If in this example, points L and M lie on segment AB and segment CD respectively, if the length from A to L and L to B is proportional from C to M and M to D, then we say that AB and CD are divided proportionally. That would mean that AL over LB equals CM over MD. It would also mean that the little part to the whole part, the little part to the whole part are also proportional. Likewise, the big segment to the whole segment is proportional to the big side to the whole segment. The first theorem in this section is the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Think back to the theorem that we used when we had a triangle and we talked about its mid-segment. Remember that theorem said that if a line contains the midpoint of one side and is parallel to another side, then it cuts through the midpoint on the third side of the triangle. Well, now when we're talking about proportionality, we mean the same thing. If a line is parallel to one of the sides of a triangle and it cuts this side into a proportion A over B, then you know that the ratio on the other side has to be the same. So A over B equals C over D. We could talk about why this is when we talk about how these two triangles are similar. If you look at the little triangle on the top and the whole entire big triangle, because those two lines are parallel, we know that angle 1 and angle 2 are congruent through corresponding angles, and angle 3 and 4 are congruent because of corresponding angles. So the angle-angle postulate says that those two triangles must be similar. The thing about this theorem that's really interesting is that you can now set up all kinds of proportions. A over B, big side to little, big to little, are proportional. Big to whole are proportional. Little to whole are proportional. Little to whole is also the same ratio. What I'd like you to do, please, is I would like you to list all of the different equivalent ratios that you can find in this particular picture. Use the lengths A and B, the total side E, C and D, total side F, G and H. If you take a look at your note sheet, you will see that the words are written out. I would like you to do this problem using the letters that are on this slide. The next is a corollary that says if three parallel lines intersect two transversals, then they divide the transversals proportionally. Think back to the theorem that we used back in chapter 5 that said if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. This is the same thing, but instead of congruent segments, we have proportional segments. So in this particular picture, A over B equals C over D. Also, A over the whole entire length has to equal C over the whole entire length. B over the whole entire length has to equal D over the whole entire length. This is where words become very important. The next theorem is the triangle-angle bisector theorem. And it says that if a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the other two sides. Here's your angle bisector. It has now divided this big triangle into two little sections. A over C, the two on the left, are proportional to B over D, the two on the right. C to D, A to B, as long as you have the means extremes product being the same, then you know that those sides are proportional. Use these two theorems and the corollary to complete the problems on the note sheet. Again, remember, the words will help.